All right, today we are diving into one of the deepest, most mind boggling questions in all of science. Seriously, this is a mystery that keeps physicists up at night, a puzzle that kind of suggests we're missing a huge, fundamental piece of how the universe actually works. But to get started, let me just ask you a simple question. What's the weakest thing you can think of? Go ahead, picture it. Is it a soap bubble? A whisper? Maybe the flutter of a butterfly's wings? Whatever it is, just hold that thought in your mind, because it is absolutely central to where we're going. You see, our universe is basically run by just a handful of fundamental forces. And for our story today, we only need to focus on two of them. Think of them as two competing players that shape everything, from you and me to the farthest galaxies out there. So on one side, you've got the macro world. This is the big stuff, the world of planets and stars and whole galaxies, all governed by a force we know pretty well, gravity. Then on the other side, you have the micro world, the unbelievably tiny world of atoms and particles. And that world is run by something we're just going to call the quantum forces. Okay, so let's start with the familiar one, gravity. I mean, we feel its effects every single second of our lives. It seems like an absolute powerhouse, right? The undisputed champion of the cosmos. And our intuition totally backs this up. Gravity feels incredibly powerful. It's strong enough to hold entire oceans to the planet. It keeps the Earth locked in orbit around the sun, and the sun itself glued inside the Milky Way galaxy. From our point of view, gravity is a cosmic giant, this unstoppable force. But is it really? Now, let's turn our attention to the other team, the hidden power of the quantum realm. You can't see these forces, you can't feel them directly, but their influence is just absolute. These quantum forces are responsible for, well, pretty much everything else. They are the glue that holds your atoms together. They're what powers the nuclear furnace inside our sun. They are the reason light even exists. In fact, you could say that all of chemistry and all of biology are just the quantum forces doing their thing. Without them, nothing as we know it would exist. Period. So there you have it, our two main characters. Gravity, the ruler of the cosmos, and the quantum forces, the architects of matter itself. Both seem unbelievably powerful in their own domains. But now, it's time for the main event. It's time to put them head-to-head and see how their strength really compares. This is the central question, right? If we were to pit these forces against each other in a direct tug-of-war, who would win? And more importantly, by how much? Go on, take a guess. What do you think? Are the quantum forces twice as strong as gravity? Maybe 1,000 times stronger? 1,000,000? I mean, think about the power it takes to hold a galaxy together versus the power holding an atom together. What feels right to you? It's not 1,000,000. It's not 1,000,000,000. It is this. That's a 1 followed by 33 zeros. The quantum forces are 1,000 billion 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 times stronger than gravity. That number is so huge, it's basically meaningless. Let me put it another way. A simple fridge magnet holding a piece of paper to your fridge is winning a tug-of-war against the gravitational pull of the entire planet Earth. That's the insane imbalance we are talking about. And this isn't just some fun trivia fact. It's what some physicists have called the most profound and embarrassing problem in their field. So why embarrassing? Because scientists have absolutely no explanation for why this gap is so ridiculously enormous. It feels like a typo in the universe's source code. This incredible, completely inexplicable gap between the forces actually has a name. And it represents one of the greatest unsolved mysteries we have about the fundamental nature of our reality. It's called the hierarchy problem. It's not just that gravity is weak, it's that it is so much weaker than all the other forces that it seems to be playing a completely different sport on a completely different planet. And we have no idea why this extreme hierarchy exists. And here's why it really matters. In physics, when you find a number that is this wildly out of whack, this unnatural, it's usually not a random accident. It's a giant, flashing neon sign pointing towards a deeper theory, a piece of the cosmic puzzle that we haven't found yet. It could be hinting at extra dimensions or new particles, or a whole new way of understanding the universe itself. So in the end, we're left with this enormous question. Why is gravity so incredibly, fantastically weak compared to everything else? Why is our universe built on this foundation that seems so fundamentally unbalanced? Answering that question, well, it might just be the key to unlocking the next great revolution in science.